but is anybody willing to share out why your kids maybe scored higher, lower than the MHI total, or what in that question you think is a distractor? And number 6 is the chart.
I think they got confused on like where it says fail to bottom, because it doesn't say, like, they want to know which one is soluble, so we know that like sugar and salt is salt.
Something about them seeing those steps and then analyzing the chart and then going to the questions. It's like they're doing 3 separate things. They're looking at everything that's stated, they're looking at the chart, and then they have to answer the question. So when you guys are doing force this week, and I already know you're doing it, teaching the scientific method, it's almost like it has to model this. And that's what we're doing, because we talked about the lessons, designing the experiment. But I think the missing component, and I think Ms. Masters and Ms. King talked about this, letting them form a chart. And I think Ms. Hannigan said 6th grade does this. You guys used to provide them with the chart, but now you get them to create their own chart. Danielle, is there something on the 6th grade test you had a concern about?
Well, you know, our lowest one was the 6.2A. Kingdom wants to find out if a physical change will occur when you shake straw inside of the pop can for 30 seconds, which the following sets of lab equipment will allow us to complete this experiment. And the answer is timer interleaving analysis.
The equipment.
Yes. The only thing I could think of to do would be to do this activity.
Yeah.
And it would correspond really well with them being able to read triple beam balance.
All right, number 8. Mrs. Ty, how did your kids do on question number 8? It's 5.58.
79.8%.
79%?
79.8, so
80%?
80%.
So we're at 57% as MHI. Your kids scored 80%. What can you tell me? How did you talk about thermal energy in your class? How did you introduce it?
Well, I actually showed them a video of this girl curling her hair and her her dog.
Wow.
Yeah. I've seen.
So she was curling her hair.
Yeah, and the thermal energy from the curling iron burns her hair off. And I was like, why is that doing that? And why is her hand not burning off? And you can bring in, some supplies like blow dryer, curling irons, or anything that you have at home, like home equipment.
On your density question.
Yes. There's
3. Okay. And 5th grade, question number 9, which is 5.5A. Mr. Sanchez, how did your kids do on that question, number 9?
44%.
44%. What do you think is a misconception there?
I would probably say most of my kids picked A, which is different states of matter, I guess, because we talked about, I don't know why they would pick, like, I guess different states of matter. They thought just because the cork and the rock were made of different material, maybe that's why they were floating. But that's the one that most of my kids picked was A.
Ms. Underlight, for your density question, did any of the kids score like 60% or over on one of your density questions?
They scored 72% on all 3.
On all 3? Mm-hmm. Can you tell us how you teach density? Can you talk about?
Yeah, I did several things. First of all, my daily warm-up was the density question. I went from easy to hard. So at first I would start out with, here's your mass, here's your volume, what's your density? And so we did that for a couple of days. And then I made it a little harder. I saw that, you know, they were going to have to find their own volume by using weight times width times height. So I made a couple of warm-ups where they're having to find their own volume, and I'm giving them the mass. And then they're having to plug in both those numbers. And then once they mastered that, we moved on to finding the volume of an irregular shaped object by actually doing water displacement. And so they actually did it in lab. They did water displacement in a worksheet where they were practicing it over and over and over. I actually had them measure mass on a triple beam, hands-on, and made sure that they knew how to do that.
Okay, so you're saying you just warm-ups, just had them do hands-on, just sort of just didn't teach it and let it go. It's just sort of practice it.
I broke it down. I mean, density is D equals M over V. So we talked about what is M, and we calculated M. We talked about what is V. We calculated V both ways. Wind tide, and water displacement. And then once they had the M and the V, it was like, okay, now we can put that into our D. Now this is what density is.
So during our science camps, we have our density person go to Mrs. King, because Mrs. King actually noticed a pattern. So MHI was at a 70% on this, and I can understand why, because we really nailed the mixture, solution, solubility. But the sand and iron filings, Ms. King noticed that her kids didn't get it, and then she came in and got a magnet and actually showed the demonstration. Ms. King, can you share out pretty much, did your kids make a connection when they saw you?
Right. So on the CFA, most of them missed the iron fouling question, which one could be separated using a magnet. And it was because they didn't know what iron filings were. So that's whenever I got the red. They used the iron filings in the sand, and then the kids separated those in those. And they were able to tell which one
The purpose of PLC is just to make that connection. How can we, almost like create our own questions, how can we make this relevant? How can we make them get this? So, all right, usually this is our time where we're winding down. Ms. Turner is here, she wants to.
I appreciate something that you honed in on is vulnerability and being transparent. We all own this data, just like we all own the banner outside. But I appreciate you all being willing to share so that we can all get better. Because that's what happens, you become an expert in different areas, and so we support one another through being vulnerable. So thank y'all.